So, increasing, decreasing. dy dx is the slope of a tangent to any curve at any point on the curve. Can be used to determine if and where a curve is increasing or decreasing. So, for example, we have a red curve here, and we see that the tangent at the point is bigger than 0, i.e. the slope is increasing because it's going diagonal right up. We also see the opposite is true, that the tangent is going diagonal right down when the slope is decreasing. So long story short, when you're on your way up, dy dx is bigger than 0. When you're at the top, dy dx equals 0 because you're turning. And then on your way down, dy dx is less than 0. That's it. If you see the word increasing, differentiate, prove it's bigger than 0. If you see the word decreasing, differentiate, prove that it's smaller than 0. So let me give you an example. Okay, let's go for question 1. F of x equals x squared minus 2x minus 8. Find the values, plural, of x for which the function is decreasing and the function is increasing. Differentiate once, and we get 2x minus 2. If it's decreasing, what does that mean? It's less than 0. Bring the 2 over the other side. 2x is less than 2. X less than 1. X is less than 1 when you're decreasing. When you're increasing, 2x minus 2 is greater than 0, and therefore 2x is greater than 2. X is greater than 1. Let's just really spell this out. So that's y equals, what was it, 2x, x squared minus 2x minus 8, was it? Is that the formula, guys? X squared minus 2x, what? 2x minus 8. Look here. That's this graph here. Okay, and I'll just get rid of the old graph for a second. Now, look, there it is there. That's the graph we just examined a second ago. Now, what you notice about either side of 1? At 1, it's turning. Anything smaller than 1, it's decreasing. Anything bigger than 1, increasing. And that's it in a nutshell. That's how it works. Okay? So, let's have a look at another one. Okay? Now, I have to explain why a function is bijective. That'll be question 3. In question 3, let u equal x plus 2, du dx equals 1, phi equals x plus 1, let the v dx equal, therefore equals 1. Differentiate, the y dx ends up to be, what's the u times the v, sorry, phi times the u dx, so x plus 1 times 1, minus u times the v dx, which is x plus 2 times 1, all over x plus 1 squared. Now look at this, guys. This is an interesting one, and this is a very popular question, okay? Minus x minus 2, x plus 1. What happens? X is cancelled, and we're going to be left with minus 1 over x plus 1 squared. Now, it wants me to say, show that it's less than 0 always. Why is this always less than 0? Right, a quick note about it on the bottom. Denominator is what, guys? Is always positive because it's a perfect square or square. Given the numerator is negative, given the numerator is negative, this ensures the first derivative is negative for all values of x. Happy enough with that? Negative, it's decreasing all the time. Okay, now what's the next part? Explain why the function is bijective. Okay, now if I was to draw this curve, it helps me visualize it. Okay, or a quick sketch. What's the function again? Y equals, what's x plus 1? X plus 2 divided by x plus 1. Okay, function is always decreasing on one side and it's always decreasing on the other side. Now, why is it considered to be bijective, is what we're asking? Well, first of all, it's definitely a function. Why is it definitely a function? It crosses the y-axis and it crosses the x-axis. It has an asymptote at -1. Okay, well technically means it's not continuous all the way through. Okay, now it's not a continuous function because it has an asymptote, right? What you notice is it's always going down. Okay, now the rule is explain why it's bijective. Okay, now what bijective means is, sorry guys, just 1 second with this. Explain why this function is bijective. It's bijective, I'll type it out. It's bijective because the curve contains no turning points. Do you know what I mean by turning points? Yeah. See, bijective turning points means that one output gives you two inputs. Contains no turning points. This means that outputs that each output only has one input. Okay, now
if that was me, I would have just said each output only has one input. Like, would that still get you forward?
So I'd say each output what?
I would say like each output only has one input.
Yeah, well, yeah, I'm sure it could do, yeah. Key words there, yeah. So guys, now what's the other thing about being bijective, if you don't mind me saying? The other part of being bijective is that each value in the range in the codomain is used. Does that actually happen? Now, I'm having a slight problem with this question, I'll tell you why. Technically speaking, the asymptote, which is located here, that value never gets reached, does it? It's undefined.
It gets very, very close.
Sorry?
It gets very, very close to it.
Very, very
close to it.
Close to it. But actually, as it turns out, it's infinity. So it's the y values we're talking about, isn't it?
Yeah.
So infinity isn't defined. So technically you do go on forever. Okay, so that's probably why it's considered bijective. Okay, so there we go. That's the general answer though, okay? Now, let's move on to number, I don't know, 4 and 5. Now, 4 and 5 are both x cubes, and they're both find the first derivative less than 0. They're identical questions. It means I only should do one of them. Okay? Differentiate, and what we get is minus 3 plus 6x minus 3x squared. And now I have to prove that this is smaller than 0 for all x values. Now this is difficult, okay? So what I'm going to do is this, guys. Anytime you want to prove that something is smaller than or bigger than, you need perfect squares. You either need a plus perfect square to prove that it's bigger than 0, or you need a negative perfect square to prove it's less than 0. So that's what I have to do. I have to make a perfect square out of this. Now, how do I make a perfect square out of this? Can anybody tell me? First of all, I make it positive. Okay? Next part after that. Before I do that even, there's a part before that. I'm technically allowed to divide both sides by 3 or factorise out 3. So I'll factorise out 3 first, okay? I'll take out minus 3 into minus 1, plus 1 minus 2x and that's much easier. Turn it around. It's less than or equal to 0. Use the reference number on this, guys. What happens when you use the reference number on that? You're going to get x minus 1, x minus 1 when you do the reference number. Okay? Is everybody happy with me just skipping that in? Yeah. And then minus 3 into x minus 1 less than or equal to 0. Explain why it's always negative. Yeah. Perfect square. Perfect square, which is always positive, is being multiplied by minus 3, hence producing a negative number for all values of x. Is everybody happy with that? No matter what value of x you put in there, it's going to be squared and it's going to end up positive. And then you're going to multiply by minus 3, which means it's less than or equal to 0. Question 4 is actually an easier version of this question. Okay? Question 5 is an easier version of this question. All you're going to get is 3x squared minus 6x plus 9. You're going to factorize out the 3. And you're... What is this? Sorry?
Plus 2.
Oh. So, actually, just while I'm here, I might as well just have a quick look at question 5 while I'm here, because this stuff's tricky. We're going to get first derivative is 3x squared minus 6x minus 9. Find the values for x. Oh, sorry, it's a different type of question, excuse me. I actually want you to find the values of x for which it's less than 0. So you actually have to solve this. Now, what type of function, what type of shape is the function? If I was to draw it, what type of shape is it? U-shaped. Okay? If I solve it equal to 0, so you're going to get x squared minus 2x minus 3. I'm going to pretend it's equal to 0 for a start. And then I'm going to get x minus 3, x plus 1 equals 0, x equals 3, x equals minus 1. That one there is minus 1, that one there is 3. Am I looking for this graph to be smaller than 0 or bigger than 0? Smaller. It's bigger than 0, it's bigger than 0, it's bigger than 0. It equals 0. Now what's going to be? Smaller than 0, smaller than 0, smaller than 0, and then back to equals. It's any number between minus 1, x, and 3. If that was bigger than 0, I'd be doing the two green regions, which is x less than minus 1, x greater than 3. So you'll always draw the first derivative if you get a question like that. So there actually are two different questions. Okay, number 7. Let f of x be x minus sine x. Show that the first derivative is bigger than 0 for values of 0, less than x, less than pi over 2. Let's differentiate. You differentiate, what do we get? We're going to get 1 minus cos x. Okay? We got to prove this is greater than 0. Okay? And what we got to prove next is that, move the cos x over to the other side, we got to prove that 1 is greater than or cos x is less than 1. Sorry? Same thing, okay? So cos x is less than 1. And what you can say is that cos x, cos pi over 2 is equal to 1, isn't it? So therefore, any value of cos below pi over 2 is less than 1. Do you remember what I was saying? Cos has a maximum value of 1. So therefore, only when it reaches pi over 2 or 90 degrees is it equal to 1. So therefore, any values underneath that, it's going to be less than 1. Okay? you could write a note about that at the end. Okay, next one, number 8. An artificial ski slope is described by the function h equals 165 minus 120s plus 60s squared minus 10s cubed, where s is the horizontal distance and h is the height of the slope. Show that the ski slope never rises. If it never rises, its slope is always negative. Therefore, another way of saying that is decreasing. H, now guys, what's the first derivative described as? dh ds. Minus 120 plus 120s minus 30s squared. I want to prove it's less than 0. How do I do that? What number can I take out of all three? Minus
3.
And I get 4 plus minus 4s, yeah? Plus s squared, less than 0. Turn it around, and what happens now? S squared minus 4s plus 4. You're going to use the reference number. Happy enough with doing the reference number on that?
Yeah.
And you get minus 30 is less than s minus 2 squared. Once again, a negative number multiplied by a perfect square is always a negative number, therefore it's always decreasing. Easy beasies. Now, final one of the batch. Prove that this is decreasing for all x element r. This is a tough one, not necessarily because of the question itself, but just because of the differentiation. Alright, sin x minus plus cos x, guys. When you differentiate that, what happens? Cos x minus sin x, and then v. Sin x minus cos x. What about the v dx? Plus sin x, because it's going to be a minus sin x, which gets me a plus sin x. Put it all into the derivative. Quotient rule, yeah? So quotient rule this, and we're going to get v times du dx, which is going to be sin x minus cos x, multiplied by du dx, which is cos x, minus sin x. We've done one similar to this before, haven't we? It's going to be u times the v dx, which is sin x plus cos x, multiplied by cos x plus sin x. Then we're going to have the bottom, which is v squared, which is sin x minus cos x squared. Now guys, it looks fairly daunting, but there's going to be a lot of cancelling going on in a second. So we're going to get sin x cos x minus, plus another sin x cos x, correct? And that will give me 2 sin x cos x. Then I'm going to do the green one. Sin x to sin x minus sin squared x, and then the blue one, which is going to be cos x to cos x, which is going to get me minus cos squared x. Okay? Now, I probably made that a bit on the large side. I'm not going to be fitting that in at this rate. So there we go. Minus bracket, same trick as last time. Sin x cos x, sin x cos x. There's 2 of them. 2 sin x cos x. Next one after that, sin x by sin x, sin squared x, cos x by cos x. Now, let's not waste any time here. What is sin squared x plus cos squared x? 1. Just get rid of it. Plus 1. Okay? Now what about this one here? This is minus bracket sin squared x plus cos squared x. See the double negative here? If I factorize that out, it becomes minus bracket sin squared x plus cos squared x, which is minus 1. Once again, don't waste any more time than is necessary. Minus 1. Then what's going to be on the bottom? Sin x minus cos x squared. Now look at this, guys. What's going to cancel now? Sin x, 2 sin x cos x cancels with minus 2 sin x cos x. Minus 1 on top gets me minus 2. We've done this derivative before. Now guys, once again, why is this going to be decreasing for all values? Numerator is a negative number, denominator is always positive. A negative number divided by a positive number, negative number regardless of what x is. Alright.